am Jeremy Rand. I go online as BioWizard89. I'm a computer science major here at OU. This report was a collaboration with Martin Michelsen. He's at Caltech. He goes by Fuzziqer software. Our research is on using video game enhancers to synchronize multiple GameCube and Wii consoles. And our work is sponsored by GameCARS. So our research involves video game enhancement technology, which modifies games without needing your source code. So this is typically done using reverse engineering and memory patching. And so things like Game Genie, Action Replay, Game Shark, things of that nature. So when we tell people we work in game enhancement, they often say, oh, so you're cheating at games. And we think that's unfortunate because enhancement is not the same thing as cheating. We follow a little rule we invented which we call the ICE principle, which basically means game enhancement should improve innovation, competition, and enjoyability of games. And it should add value which the game didn't originally have. So we're not interested in things like sabotaging online leaderboards. We have no interest in that. We don't cheat, we enhance. So our work focuses on online enablers, which is a class of video game enhancers which allows offline multiplayer games to be played over the internet. And it's consistent with the ICE principle. It's innovative, competitive, and makes the game more enjoyable. And this is not a new idea, but it's not very well known either. So a little history lesson. The first online enabler was the X-Band, which debuted way back in 1994 for the Super Nintendo and Sega Genesis consoles. It was basically a combination of a 2400 baud modem, yes, that's slow, and some specialized software which patched games to intercept two-player activity and redirected it over the phone to not allow games to play online. It supported 38 games, but it was discontinued 3 years after its release. So the X-Band was awesome, so why the heck did it die? Well, it had some scalability problems. The company behind it had to maintain network infrastructure of their own. They had to manufacture and distribute the modem hardware. They had to individually patch each game to handle online play. And they did not have enough employees to really scale up this process. So as more games came out, they were completely in trouble. It was also complicated by the fact that the internet connections of the day were extremely slow, very high ping, and that made things way harder for them. As a result, X-Band did not last 3 years. So we wanted to basically fix the X-Band model. And how do we do that? So the first step was use modern networking. We can use peer-to-peer networking. We don't have to run our own servers anymore. And we are going to assume this time that everyone has broadband by now, which is mostly true. We want to use existing hardware. We don't want to have to manufacture and distribute stuff for them ourselves, because that's a huge bottleneck. We don't have the resources for it. We want any hobbyist who's reasonably good with computers to be able to add support for new games on their own without directly involving us. So how do we do that? How do we make adding support for new games something that standard hobbyists can handle? Well, game enhancers like Action Replay offer a really, really good solution for that. There's a large community of game enhancer code authors already out there. And if we make adding online support to a game as easy as making a game enhancer code, well, then we all win. So that is what we did with our GameCube online enabler, which is called GameCube Action Replay Simulator and Control Simulator, or GCARS-CS. It implements a code engine with exactly the same format as the Action Replay, but with the ability to synchronize data over the network rather than repeatedly loading just the same data over and over. And so this allows action replay code creators to bring the GameCube online. So here we have an example of an action replay code for 0 damage, and a GCARS-CS code for synchronizing damage, and they are the exact same code. So under the hood, GCARS-CS works by placing a 32K code snippet in unused memory. It hashes the game to run this every frame. And by the way, that patch to run every frame is just another action replay code. And every frame, we process an action replay code that specifies where all the game state variables are. So things like controller data, XYZ coordinates of players, health, weapons, things like that. We run an action replay code to find out where those are. And instead of just overwriting that data with the same thing each time, like a standard action replay would, we exchange those variables over the Ethernet adapter that's available for the GameCube. And this allows the games to stay synchronized on multiple consoles. So here we have an example of Super Smash Bros. Melee, which is the best-selling game on the Nintendo GameCube, being played online. Looks mainly like a standard match. All their cute glitches. When we wanted to port GCARS-CS to the Wii, we had some ideas for possible improvements. We decided to use an existing Game Enhancer backend rather than recoding our implementation of a code format. And that's because writing lots of our own code is kind of what killed X-Band. We don't really want to go there. We also decided that anything that the Game Enhancer we're going to use didn't already support pretty much built in, we were going to offload that processing to a PC. Because PCs have lots of RAM, you can code them in C++ easily, it's awesome. Whereas GameCubes and Wii's don't have much memory, you have to code it mostly in assembly. It's really annoying. And also, you can do a lot of things with game synchronization that doesn't involve online play. I mean, we want to investigate some of those other possibilities. I'll elaborate on that in a few slides. As it turned out, there was already a game enhancer that fit our needs very, very well. It's called GeckoOS. It's a free Wii program. It's similar to Action Replay and how it works. However, the code format is much, much more powerful. For example, you can actually embed assembly code directly in a code without any kind of crazy memory management on your own. And it also has a built-in remote debugger, which can be used to create codes using relatively cheap hardware. It's called the USB Gecko adapter. At least it used to be cheap. It's gotten kind of expensive these days, which really annoys us. We struggle on that. And GeckoOS supports Wii, WiiWare, Virtual Console, and GameCube games. So in theory, we could have it replace GCARS-CS as well. So under the hood for GeckoTunnel, which is our Wii port, we compiled the USB Gecko adapter driver for the Wii. It was originally in C. We compiled it into assembly. We then embedded that assembly in a standard GeckoOS code. And I mean, all that code was already there. We didn't have to write any code there. And then we used GeckoOS codes to figure out what addresses to sync. And again, that's what game enhancers are made for, so that was really easy. And then, once we find what we want to sync, we just call that function that we embedded in an assembly GeckoOS code, and it transfers the data from the addresses we found using USB Gecko every frame. And then we have a PC client on the other end of the USB Gecko adapter, which bridges into the network so you can play over the internet. And yeah, it really is pretty much that simple, at least conceptually. Implementation is a bit more complicated. Okay, so this is an example of Wii's playing online. Here we have one of the Sonic the Hedgehog games. So this is a LAN match.
Generally, so can you find out what is V1 and V2 for? So V1 is being played on one machine, right?
Yeah, okay. So this here is one of the ways. This here is the other way. And this is player 1 on his way. This is player 2 on his way. This is what player 1 sees from player 2. And this is what player 2 sees from player 1.
So this is synchronized over the network?
Yes, it is synchronized in the game so that they're playing over LAN. So even though the game had no LAN mode originally.
Originally it's not there, so you incorporate this particular code to be able to do that?
Yes, that is correct.
How far are they from each other?
Let's see. These were on the other end of the house, so that's why the lag here is really minimal. But we've done some things even over dial-up connections across the continent, and it's still pretty playable, which is kind of cool.
How many players do you allow?
I'll get to that actually.
All right.
All right. So, as I said earlier, we can do things other than just online play. So, if you redirect the player data to a file rather than another way, you can record gameplay. So, player 1 just moved around, like right here, and now we're replaying that data on player 2. So player 2 is moving exactly how this player has just moved. Pretty much down exactly to the pixel. What's cool is you can actually interact with the recording like that. So this is actually quite a bit better than using a video capture card, because capture cards would take megabits per second to get good quality. The data we're capturing with this is basically just where the player is in the level. So I believe the bit rate here is 14.4 kilobits per second, and that gives us 60 frames per second lossless, which is much better compression than a capture card would give you. If you instead redirect controller data to a USB gamepad that's on a computer, or anything that emulates a USB gamepad on a computer, you can get alternate input devices on the Wii, which the Wii would not normally support. For example, USB gamepads, as I said, but also Wiimotes for GameCube games. You can do virtual reality gloves, voice commands, connect 3D cameras, head trackers, and believe it or not, EEG-based brain-machine interfaces. So yes, using the code that we already have, you really could go out and buy an EEG-based brain machine interface for about $200 and rig Mario Kart so that you have to concentrate really intently to be able to accelerate, if that's your thing. Meditation lessons not included. Here's another cool thing you can do with using a USB gamepad to supply controller data. Super Smash Bros. Melee, which we're looking at again, it has a secret mode that allows 6 players rather than the standard 4. Except the GameCube and Wii, they both only have 4 controllers. So where do the other 2 players come in? Well, normally they're computer controlled. However, if you supply players 5 and 6 with controller data from a USB gamepad, you can actually control those other players with human supplied data. So here we have a 5-player match in Super Smash Bros. Melee. Every player that's moving around is a human player. And yeah, so we're hoping that once we work out some glitches, this may lead to a whole new renaissance of Super Smash Bros. Melee combos with 3-on-3 battles or something. We like immersive games. Immersion is a really cool thing, especially virtual reality. We would like the Wii to be a bit more immersive. And this includes things like camera enhancement for virtual reality. So what we want to do is use a head tracker to supply data directly to the camera variables. We don't have that working yet. However, we did figure out how to access the camera variables, and we have a proof of concept which implements stereoscopic 3D. And for those of you unfamiliar, stereoscopic 3D is what's used in 3D movies. Basically, each eye sees a different view, and that produces a sensation of depth. And we have an overview of that here. There we go. All right, so this is F-Zero-GX, which is one of the best graphics games available on the GameCube. It's still like good for compared to other Wii games. This looks like a split-screen multiplayer match. It is not. This is a single-player match. However, we're rendering a left eye view and a right eye view. If you look very carefully, you can see that this guy's car is offset a few inches from this guy's car because different eyes are viewing it. And if you have a 3D TV, you can plug this in and you can play games in 3D. If you don't have a 3D TV, there's a program available for the PC which will convert this into standard bedside and English classes, which costs like $5. And we've actually tried that out. It works pretty well. And we have some breaking news. This is brand new. You're the first to see this. It's just worked for the first time about a week ago. Let's have a show of hands. How many of you have ever played a video game and wished it supported more players at the same time than it did? All right, yeah, me too.
It's an exclusive club.
It turns out, if you're playing a game over LAN or internet with GeckoTunnel, and let's say you have 6 players who want to play, but it's a 4-player game. Well, you don't actually need to see all the players. You just need to see the players who you're likely interacting with. Now, how do you determine that? Well, XYZ proximity, you're near. These 3 players are near you. They're the ones you're probably going to be interacting with. So what we do is we have this little thing we call the multiplexer, which determines every single frame which players are likely to be interacting with you based on XYZ proximity. And it basically hides the remaining players that aren't in that list from you. So the 4-player game sees the 4 players it expects. These players are visible, and these are invisible until you move near them, which one you'll see them instead. Which is really awesome. There we go. All right, so this is an example video of multiplexing used with Sonic Adventure 2 Battle, which is what we work with. Okay, so notice that a player just appeared up there as we walked near him. And now watch, if we go moving away, he just disappeared because we're now closer to that character. I'll look at that one more time so you can see it again. Here we go. All right, see there's no character up there. We're near this character here. Walking toward, character appears. So this works really well for a lot of genres. Racing games works really well for first-person shooters. It works pretty well for, unless you're doing things like sniping. So we believe we are the first people ever to do something like this. And assuming there aren't any technical issues, we're going to have a live demo of 3-player Sonic at the poster session. So I highly recommend you stop by and hopefully you have that working. Hopefully you don't have technical issues there. There's a lot of people we deserve thanks for their contributions to the stuff that we used in developing this stuff. In particular, James Gilchrist sponsored our work, sent us a donation, and Dr. Tritton supervised the work for honors research credit, and a lot of people contributed in various technical ways. I can't name them all by one, but thank you to everyone here.
So here, the enhancement is that the enhancement is to allow more people to play in remote place, from remote place.
Yeah, so basically, if you have a game that's normally 2 players,
Yeah.
you can play with as many characters as you want, basically. As many players as you want at the same time.
Can you explain, so you used the existing enhancers, then you enhanced them, right?
I'm sorry, say it again?
You said you talked about some enhancer code already. available.
Yeah,
Right?
right.
Where exactly is the innovation in this one? What exactly is the difficult part?
Okay, so the game enhancer we're using, which is called GeckoOS, it's mainly designed for things like giving you infinite health in games, things like that. What we're doing is we have repurposed it for the purpose of actually synchronizing variables with other consoles. So rather than just overriding a variable with the same value every frame, which is what the GeckoOS normally does, we have it retrieving data from other game consoles and poking that data into the game console it's running on, and then it dumps the data and sends that to the other consoles so they can get the data. So basically we're synchronizing multiple consoles. That's what we've done.
How much code did you write to do the synchronization? Approximately.
I don't know how many lines. It's, I want to say about between 10 and 15 C++ classes, most of which are fairly long. Yeah, so this is the URLs where you can find us. If you're all interested in beta testing for us, or just want to see what we have, feel free to stop by. And we have time for questions.
Could you go back to the adapter that you think can attach with EEG or EEG?
Sorry, what?
The ring.
The brain wave catcher.
Okay, yeah.
Yeah.
I'll go back there.
Okay, good. So here, as somebody plays the game, you think on the side you can also visualize the brain activity.
Is
that the?
So the brain-machine interface, which would probably be used for this, there are two that are on the market right now. Two brain-machine interfaces that are usable for this. One of them is called the Emotive Epoch. One is called the NeuroSky Think here. And they can both emulate a USB gamepad, which makes it really easy for us to link them in with Wii games. So basically, you would configure it, for example, let's say you wanted to do the Mario Kart example that I said. So you would basically configure it so that a certain brainwave pattern is mapped to the accelerate button. And when you have that brainwave pattern, it would send the accelerate button command to the game, and you would accelerate. I can't afford an EEG-based brain-machine interface right now, so I have not actually used that. However, all the code is there. It will work with anything that can emulate a USB gamepad, including the EEG. Any other questions? Yeah?
I don't have that much information about the game development, but as far as you said, for example, when a game is allowed to have 4 players at the same time, when you want to play with 6 players,
Right.
Does it relate to anything to the game engine also?
Can you elaborate on your question a bit?
I mean, as far as I know, there is a game engine which is the game is based on that game engine. So
Right.
when you change the code, did you change anything related to the game engine also?
Basically what we're doing is, for every player we have basically a struct, which consists of various variables such as controller data, XYZ coordinates, things like that. So what the multiplexer does is before it sends the player data from your opponents to your Wii, it checks what the XYZ coordinates are of each of your opponents, it checks what your players' XYZ coordinates are, and it chooses the players that are closest to you in terms of XYZ proximity, and then it sends to your Wii the players that are closest up to the limit of players that the game supports. So it can be a little bit tricky to avoid certain glitches if you switch players at exactly the wrong time. So there are certain variables you have to synchronize if you're doing that you wouldn't have to synchronize if the game didn't have multiplexing. But it works relatively seamlessly. If you want to take a look at it, stop by the demo after the mature session.
Thank you, Jim.
Thank you.
Let's